Okay. Yeah. So the midterm project is actually find the literature here. Find the literature that you are going to do, and then try to how to say, present that literature. Okay. Okay. I hope that one will be clear for this particular project. Next, let's try to discuss the assignment 3 and 4. Okay. Meanwhile, I also open the slides here. Assignment 3, assignment 4. Okay, we will discuss this one today. Okay, let's see from the question. Okay, assignment 4 here. 3 and 4 here. Okay, so this one I saw only how many people respond. 11 respond, and it came from, I guess, only 1, 2, 3, 4. Only 4 students submitting the assignments. Okay, so I hope that after we discuss this, it was week 3 this week. Ah, really? No. Wait. This week is week 5, right? Wait. Let me check. Send a PPT that shows the details of the midterm final report. Thank you. Yeah. I will send that one. Wait, if we this one week 3, 4. Yeah, this week is week 5, right? The 5th week. Okay, maybe like this. Let me ask the dean first the schedule for when will be the last time I should submit the midterm score. In case it should be next week, then like this, we will just use the assignment 5 score as our midterm. Okay, so try to do the assignment 5. If it is next week, so 17, we will go back to the original plan. Okay, so I try to make your life not really stressful. Let's just, how to say, let's make this this class is not really stressful, but you still get something out of it. You can still learn from the materials that we discussed today. Okay, so if the deadline for submitting the midterm score is next week, so we will just use the assignment 5 as the midterm. Okay, so you do assignment 1, assignment 2, 3, and 4 as the assignment score, and then assignment 5 we will use it as the midterm. Okay, but we will still do the final project, so don't worry about it, but you just to follow with the schedule. Okay, this week 5, next week 6. I think next week will be the last time we need to submit, but let me ask first. For assignment 4, yeah, again, I will mention only 4 people submitting it. And I already extend, so today is only week 4, 13, 19, 26. Oh, okay. So today is week 4. Okay. Sorry about that then. If that's the case, so we will go back to the original plan. We will use the December 17 to as the midterm. So you will need to present. I'm not sure the time will be enough, but first you need to make a video about your presentation, about the paper that you want to present. In case you are lucky, you need to present it live during the class, so I can discuss about it. But if not, I will just randomly choose. If you are not chosen that day, then I will grade the midterm based on the video that you send. I think that will be easier for everyone instead of just waiting everyone to finish presentation for the particular class. Okay, thank you, Miss Gerlin, for reminding me about the schedule. So this week is week 4 then. I think it's good. Week 4. Okay, mathematical models. Oh, yeah, okay. Next week will be week 5. Okay, okay. Okay, so we discuss week 4 first. Okay. Sorry. The material week 3 and week 4, the way I discuss about it is, let's discuss the question. Okay. You still allowed to revise your paper, your answer anytime until the end of the module 2 grading. Okay, so it means like December 17th. December 17. Yeah, it's correct. December 17. If you are not satisfied with your score, try to do the assignment again, and then you will get it until 100 at the end of the module 2 and module 1. Okay, let's start this one. Okay, since this one is combination of module week 3 and week 4, so we have two types of questions. One will related with this facility location models or problems. Another one related with the AMPLs. Okay. Okay, let's start from the first questions. This one discuss about covering problem. Okay, so this will be here. Covering problems is this one. So there is two type of covering problems that we discuss in this module. The first one, so-called set covering problems. The second one, so-called the maximum, I forgot the maximum covering location models. Okay. The differences between these two is that it's mentioned here. Set covering problem can be considered as a general form of covering problem in which we want to locate facility. Yeah, here. Set covering problem. You want to locate a facility or two. Yeah, it depends on how many demands you have. It's just you want to locate as minimum as possible facility to cover all the demand. Okay, to cover. That's why they call it set covering problems. So the lower the number of the facility you need to use to cover all the demand. So the keyword there is cover all the demand with the minimum number of facility. That one is set covering problems. In set covering problems, there is terminology called coverage. Okay. How do you describe one facility, or how do you say that one facility can cover a particular demand nodes? Okay, so in here there is several options. Yeah, so here actually the answer you can find it here somewhere. This one, surface, yeah, okay. Coverage, yeah, coverage is okay. If the shortest path distance between demand node and the facility node less than the equal coverage coverage distance determined by the input. Let's say you have coverage distance of 10 kilometers for every facility located. For example, oh, I have a firefighter station. Okay, I put in one location. Let's assume that 10 kilometers from this location will be covered by those particular fire station. So it means that if there is a fire happens, less than 10 kilometer from this fire station, they will ensure, the firefighter will ensure that they will be able to take down those fire because it's in their coverage. Okay, if it is not, so they are not guaranteed that one, because it may be, they may become late or something like that. So here you just need to know that a facility can cover some demand is confirmed based on what? Based on the shortest distance between the demand node and the facility. It should be what? It should be not more, but it should be less than the equal coverage. So the answer is this one. And then here, regarding cover model are true. Okay, let's check. Okay, so actually all of this is true. Why? Because first, the more facility being located to cover the demand area, the more percentage demand are covered. Okay, this one is based on this theory. If you see, the more facility here, you can see the more facility. Yeah, if you allocate more facility, the more demand are going cover, being percentage demand are covered. Okay, so that's the meaning of that sentence. And then wait, what happened? I cannot plug. Okay. Second, the more facility being located to cover the demand area, the less incremental demand coverage. Okay. It means what? Okay. First is like, if I allocate only one facility to cover the demand, of course, the percentage of the total demand being covered will be not many because the facility is less. Okay. If you are allowed to add more facility, the possibility of percentage demand coverage, of course, will be higher, right? So the first sentence mentioned that if you have more money, you can allocate more facility, then the more demand is being covered. However, in other case, if you have more facility, sometimes the incremental of demand coverage is not much. At some point, the incremental of the percentage demand is not much. Why? Because it's already being covered by the other facility. So if you can see here, this experiment show that, for example, if you allocate from zero facility, no demand being covered, right? But if you allocate one from 0 to 1 here, you see, the increase is like almost several hundred times. Okay, and if you start from there, if you allocate more, okay, from one facility to two facility, the percentage of demand being covered is less. Okay, because the for example, if only from 0 to 1 facility, the possibility you can cover all of it 100% or a big chunk of it. Okay, but for the next facility, of course, you should reduce the possibility of covering the demand that's already covered before. That's why the incremental demand is less and less. Okay. Next. Here. The objective of set covering problem is to find minimum cost set of facility among finite set of candidate facility so that every demand is covered by at least one facility. Yeah, this one very much true. Set covering problems allocate as minimum number of facility as possible to cover as much as demand possible. But for set covering problem, to cover all the demand in the area that being considered for the problems. Okay. Yeah, the key point is all the facility should be, all the demand should be covered. And then, but you need to use as less facility as possible. And then the next one is one key problem with the associated with the set covering model is number of facility that are need to cover all the demand is likely exceed the number that they can accommodate. Okay, so for set covering problem is that where is it? Set covering problem, this one, right? We want to cover all the demand in the area. Sometimes or most often, it is not possible. Why? Because building one facility, it's already take a lot of resource, take a lot of money, take a lot of investment. Sometimes it is not possible to cover all of those demand. So one key problems when you use the set covering problems, normally it's not applied to the practical situation because the number of facility, yeah, to cover all the demand, it's normally will be more than the number that we can actually build. Okay, the budget normally will be too high to cover all the demand and so on. And then here, yeah, this one is move to the next one, the center problems. Okay, center problem. Center problem is different with facility set covering or demand maximum coverage location problems. It is more like, yeah, you can see here. The objective is to minimize maximum distance between demand and the nearby facility. Okay, so let's assume you want to open one facility somewhere here, for example. No, we need to use bigger one. Facility here. Okay. And then you have the demand here, 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 here. You can open here. So actually, what the let's say all of it will be covered to this depot, right? So for PMAD center problems, what you are excited about is not the total distance of this to cover all the demand, but what do you want is actually to minimize the maximum distance. Okay, so you want to reach the furthest point from the facility as that can be done as using minimum time as possible. Okay, so that will be the objective. And then it can be considered as the variance of set covering problems because, yeah, as you can see from the picture earlier, this one here, right? Set covering problems is their main problems actually, their parents problems. So the researcher extended to maximum covering location problems and minimax or center problems. So they are actually the same, but for maximum covering location problems, they relax the constraint of coverage requirement. So not all of the points should be covered, but here they relax the coverage distance. So it's assumed that every node can be reached by the facility at facility at any points. Okay. And then next, variance of covering. Yeah, this is okay. A variance of covering location problems. That the coverage requirement is relaxed. Oh, this one belong to maximum covering location problems. The number of facility determined exogenously. So it means that we decide the number of facility we are going to use. Okay. It is different with the set covering problems. The number of facility being used become the objective value, objective function value. The one that you need to search for. But here for covering center problems, we will ask them to have at least p number of center. So it's more sustained compared to the set covering problem. Okay, now to ask you your understanding about the models. We discuss about it. Then here I ask you the which one is input. Okay, input or parameters. Okay, there are several technology. We have set. Okay, we have set that can be an input. Okay, see here. Set of something, here we have set of demand nodes, set of candidate location. It become input or parameter because we need to take this from the user. The value of this set will be from the user. Another one is distance from each facility to each candidate facility. That's another input or parameters. And then we have demand, we have number of facility, and for center problems, we have another. This one is a variable. Okay, the one that we calculate variables. Okay, the one that we try to decide. Okay, it's called variables. The one that we try to set is decision variable, to be more specific. Okay, here, which formula is not correct? You may confuse here because I saw it's the same in the slide. Okay, so basically I made a typo here actually, but I think that instead of I reduce it, I try to make a question about it to see if you understood the concept. Okay, so it is actually like this. If you can see here, there are several things that I suggest. Number one, objective function, minimize cost, but here we use the distance to represent. Okay, this one have the cost. We want to minimize cost, but here distance multiplied by decision variable multiplied by what is h? H. Here the demand. How does it represent the cost? Yeah. So somehow you can actually, if you have chance to do this, some people is confused with the how they approximate cost. For this one, actually you can change the DI to cost from I to J, then it will be already become estimating cost. Well, actually the one that has more crucial is that, well, actually here, this is belong to the constraint that we consider in the center problems. But here we use it for median problems. Okay, so this one actually not correct because W is not yet identified, and then I don't know what for is this one. Okay. Wait, where is it? Sorry. Where is the here? No. Oh yeah. Okay. Next. Basic mathematical model consists of, okay, this one I almost always saying this in my presentation. If you want to do mathematical programming, you should know what is the data, what is the variables, what is the constraint, what is the objective function. Sometimes it's formulated in mathematical formulation, so you need to understand mathematical formulation before you able to use mathematical programming. Okay. Up until this point, do you have any questions? Because there is like only one and two. Then we will go to the practical situation where we try this one and then see the result. Maybe one more answer. That the statement below are true for solvers. Okay, first you need to know what is solver. Solver is kind of a software. Okay, software that accept mathematical models and then translate it into some things or algorithms that the computer can use to harness the how to say, the power of computational from person, either only personal computer now already very sophisticated computing powers. And then visibility, yeah, where is that the solver is able to compute valid solutions given enough times. Okay, and then we have terminology in the OR that we want to find optimal solution out of the things that we are going to discuss about. So solver has the ability to compute those things. Okay, to complete optimal solution out of very complex mathematical models. Uh, so to select solvers, it's not easy task to do, but normally we will be first. Normally we will start from the things that we learn at school. So for you, you may understood the Excel file first. They have also the software, and then you can move on to like more sophisticated tools like Pythons or any other things. Okay, here now we discussed about the p-median in more details and try to do it as practice to use AMPL. Okay, but before that, I may want to drink some water first. But if you have any question, please leave it on the chat column. Okay, then I will as soon as I come back, maybe in 10 minutes, I will try to answer your question. Okay, let's have a break for 10 minutes from now. Okay. Okay, hello everyone. I just finished drink some water and okay, let me check. I think week 5 assignment is still okay as a midterm. Okay. Yeah. During the Christmas break. Oh, okay. I understand your point of view because too many assignment already, right? Okay. Uh okay. Let's do it like that. Let's use week 5 as the assignment for the midterm, but I still hope that you find a way to finish the final project. Okay, so start from the week 6. I will ask you to update the final projects weekly. Okay, so uh, let's reduce the assignment. Start from the week 6. Maybe there is no more like this. Try to do this and that. Try to do let's just stick to the this one, multiple choice. Okay, so that will be easier to do for you, right? Okay, so the part that is need to do the experiment like this one, let's reduce that part, and then let's just do the what is this one called, multiple choice. Okay. um Wait, where is it? Okay, now because some students have difficulties to do the AMPL, let me show you. How to do the ample for, let's use this one as an example, P median problems. Okay, so first of all, you of course you need to have the software. Okay, the software, I already sent it to you, this one, in the Blackboard, right? Blackboard. Okay, and here you go, week 4. uh Here there is a AMPL software. Okay, you click this one. Okay, and then there is a zip file here, AMPL ID zip, like this. Then you try to download it. Okay, try to download this one, right? Download. Okay, and this one, you will have this one downloaded. Okay, assume that we will finish this download. Okay, then you will have, like, for example, AMPL here, this file. Yeah, you cannot directly use this one. Okay, if you click 2 times, it will appear like this, right? Perhaps if you have the WinRAR or any zip file opener, it will appear like this. You can click the ample ID as well. It's run well, but you cannot run the solver from this software. Okay, the first things you need to do is to extract here, extract the file so that you will get this one. Okay, ample ID ms64. Okay, and then you go to in that folder and then find a MPL IDE and then find this file mplid.exe. And then when you click this one, it will show the, okay, let me show the software like this. Okay, yeah. So the software itself consists of 3 parts, 1, 2, and 3. Okay, at first you will not have this one. Okay, it will empty like this. This will be not here directly, maybe it will be in the, like this. Okay, let me tell you that this 3 part has its own function. Okay, first, the one that actually it's explained in the slide and then in the video as well. Okay, so first is that in the middle here, we call it console tab. Okay, so this part of the software is for what? Is for the the command or the instruction that you will put to the software to tell the software what they need to do. Here, the console part. On the right, it's like the part that you can use to show whatever file you click here. Normally it will be text file. Okay, so it will appear on the right here. And then this part is the directory folder file. So whatever file that you are creating, you need to make sure in order to run the file, you need to make sure that the file is in the directory that you are currently work on. For example, if you want to run AMPL, something called let's say pmedian .mod, something like that. If you not put the model.mod file in the current working directory here, they will not be able to run it. Okay, so first you need to go to the folder that I already you need to download first the several example about AMPL that I already sent to you earlier. What is it? This one, AMPL example. Okay, you can click here and then okay, you can see there are several example including covering problems, including maximum covering problems, p median problems. Okay, yeah, p median problems, and there is travel and salesman problem as well, maybe, not sure. Yeah, here. And then there is also VRP problems. Yeah. Okay, I'm not sure, maybe it takes time to load, but you need to download that one. Okay, and then after that you will be able to let's say like this, you download and then okay, you need to, let's say, from this one. Okay, after downloading the file, maybe you can move it to, let's say, documents, maybe. Okay, and then again you need to extract it as well. Extract example. Oh, no, maybe extract here. Extract file, maybe. Yeah, example ample. Yeah, where is it? Why I didn't see? This one, example ample. Okay, you need to make sure. Again, let's go back to the AMPL. So you need to make sure that you're working on that folder. So it will be C user HP from the one that I just put documents, and then example AMPL. Okay, then you will have several example here. Now we discuss about how do we implement this one, for example, right? Where is it? This one, p median models. Okay, so first is like this, you need to understood the model first. Okay, let's say let open that model here. P median model is like this one, right? Except this part, this is not correct, as we mentioned in the paper. This one is not needed for the p median models. Okay, and then you see here we have the inputs, the parameters, we have here the sets, the parameters for the data, decision variables, objective function value, and the constraint. Okay, all of this part we need to translate into their AMPL form. Okay, well, actually you can see it here. There is several. This one give you step-by-step guideline, but for covering problems. But since you are doing the p median for the assignment, so let me show you. First, here, what you need to do is, what is it here, right? Find the optimal objective value with p equal 1, p equal 2, p equal 3, and then so on and so on, okay? And which p you will select and why, okay? There is no right or wrong answer here for the second part to select the p. But for this one, it's absolute. You need to first run the p median model, in which I already give it to you here, p median, yeah? So first you can open this one. There is a model data and this the data, the data. So in AMPL, we separate the model and the data. Here, as you can see, I want to show you step side by side maybe. Okay, here is the model and here is the mathematical formulation. Okay, you can see here. Okay, first, what do we have? We have set I and set J, right? So here, set of demand nodes, right? I, set of facility, what is it? Facility, J, okay? So you have here, set of demand, set of facility, okay? And then what else you have? Demand from I to J, where I equals to, where I belong to demand nodes, J belong to the candidate of the facility. So here in the AMPL, you also have param dij, because it will be the input from the user. Distance from one location to another location, in which the first index is the demand location, the second index the candidate facility. So demand ij. Yeah. Sorry, distance from I to j. Next, what do we have here? Hi is the demand. So yeah, at node demand node I. So hi. So basically, it's just mapping whatever you have in the models. Let's say P, number of facility to be located. Yeah, number of facility to be located equals that. Okay. Next, okay. Okay, all the input and parameters is done. The sets also done. We need to define the decision variables. See here, decision variables. Okay, xij, yij, xij, yij, something like that. And then what else? After you have the variables, okay, you see first here the variables is binary, both are binary. Yeah, this one, okay. Demand nodes at I are served by K. So here we also have the X will be binary, xj, okay, whether you want to locate at facility K or not. And then Y will be if the demand at nodes I are served by facility J, okay. This is the assignment Yij. But this one should be binary actually as well. So you should put it binary. And then next is the here. Okay, after you finish with the decision variables, then we move on to the this one. Objective function, we have a sum symbol here, right? Summation. So we have here also summation. Okay, and then the hi di yij here, xi di yij. Okay, next, finish with the objective function. We discuss about the here the constraint. Okay, constraint, the first constraint. Here they write constraint 2, but here we write constraint 1. Okay lah, doesn't matter. To write this one, you start from first, define this one, subject 2. to tell them that this is a constraint. For a decision variable, you just follow this one, minus, minimize, then minimize, something like that. And then this one, the first constraint. Okay, the way you read the constraint and then rewrite it in MPL, you start from the one that back here, all I element I. So here you will have constraint number one here. Use the curly bracket, all I in I. Okay, next. After that, you will have start from this one. Sum j element j, yij equals to 1. So sum j in j, yij equals to 1. See, you just need to translate them. And then here, they don't have for all. So here, the constraint 2, you see, there is nothing before the dot here. But for the previous one, before the, what is it called? Colon, they have for all I element I. We basically just follow the mathematical model. So sigma j, sigma xj equals p. So here, sigma xj, sum xj element j xj equals p. This one, make sure the allocation is not more than p. Okay, number of the things that we can allocate. And then this one, yeah, yij less than xj. This one they have two for all I, for all j. So how do you write this one? Like this. For all I in I, j in j. So 2. If you have 3, yeah, just put comma and then put more. And then yij less than xj. So, well, I move this one all to the left, so it becomes yij minus xj equals to 0. So it's basically the same constraint actually. And as I mentioned earlier, that this part is not necessary. This is belong to p-center problem, so I don't write it. And then this one is already covered. Yeah, it's a binary. It's already covered here. Okay. And then now let's try to run it. Okay. So who's earlier? Oh yeah, Mr. Eric. Have you seen the demo earlier? So is there any problems with this? Did you get some things that you may miss previously so that you cannot run the code?
Yes, sir. I saw the presentation. Thank you, sir. But
Okay.
this one I still need to process a bit. But I saw the presentation.
Okay.
Thank you
Okay.
about that, Prof.
Yeah. So it's very easy actually. Maybe you just miss some steps so that you cannot run it. And now let me continue. After you set up all of that, you understood all of this previous one. So basically, you just need to create these two files: the mod file for the models, a dot file for the data. Okay, the mod file is already okay. Now the data. You will have something like this, right? This is only considered the model. And then when you have the problems, like let's say here, you have the data like this, right? Okay, the demand facility is A, B, C, D, E, F, E, F. So demand facility also it's equals with the candidate facility, which is also the same size. So the way you represent this one in the data is like this. You have a set of demand, right? A, B, C, D, E, F. This set of demand also serve as the set of candidate facility. So you can open facility in A, B, C, D, E. Okay, so you have two sets, set I and set J. So here just the declaration of the set. Here you put the value in that set. Next, what else we need from the user? Param data, okay, Dij. So you write it like this, D, I, and then J, okay. From I is A to A, of course, the distance will be 0. From B to A will be 9, and then its reciprocal. So it means that for this one, we are having the symmetrics. You go and go back, you will have the same distance, for example. So A to B is 9, of and B to A also 9. So you provide this also to the data. In real case, it will be like what? It will be like the city perhaps that you consider as the location of the demand, and then you calculate the distance from that city to your warehouse, something like that. And then demand, yeah, because this is just example, so we just use the equal demands is 1111. I don't know what is the measurement unit for this one, but at least it's one demand unit, something like that. And then the param P. So P is determined by the user for these particular problems. That's why I am asking you to here, try to experiment with the P number. You can change this part from 1, 2, 3, 4, 5, and 6 and see how the result will be different from one to another. Okay, now you have the complete data model and data. You can try it. How to try this one? Okay, this is a syntax that you need to study. There are several in the internet, also in the manual books. First, you need to declare the model. Models is median.mod. Then you declare the data. Data is median.dat. And then you select the solver. In this case, I only have one solver. I don't have Cplex, but I have the solver called Gurobi. Option solver Gurobi. It's also fast software. You can search their website to see how good they are. And wait. Option. So you see, just a little bit mistake is not tolerated. Option solver Gurobi and then solve. See, this one, the objective is 0. Wait, I'm not sure. Maybe. Sorry. This one. That's right. We said option solver gonna be. Wait. No. This is correct already. Wait. 6 because one, 2, 3, 4, 5, 6. Yeah. If you put all the facility in every node, so there is no distance you need to use to serve every node, right? Because every node serve itself because 0, 0, 0. Okay. Now let's try to just open one facility. Model median.mod data median.dat option solver Growy. So to see this one, objective is 55. What does it mean? It means that based on this mathematical formulation, right? Okay. The total of HI multiplied by DIJ multiplied by the assignment from one particular facility to each of those facility is equal to 55. Okay. If you want to see which facility is being open, you write display and then X. So you see that facility C is the most optimal to be open if you only have one option to choose. Okay, let's say the budget only able to serve or enough to open one facility, so it will be like this. And then if you want to show the assignment, it will be Y. Okay, so you see A also go to C, B go to C, C go to C, D go to C, E go to C, F go to C. Okay. Now what I want you to do is like this one. For the AMPL here, you need to solve it for P equal 1, P equal 2, 3, 4, 5, and 6, and then select which one is the best. Okay. For example, here, I have this one for the result or equal to 1, so I take 55, and then they open C. Let's say I try to have two facility now. Okay, so just do it again. Model median.mod data median.dat option solver Robbie. So see 35. Huh? What is it reduced? Because we allow to open more facility. If you allow to open more facility, so the coverage is larger, right? And then the distance for each demand point to that facility, particular facility also less. Okay, so display which facility are being opened. You can see display X. Okay, E and A. Why does C is not selected? Because selecting A and E, if you are allowed to open two, is more efficient. Something like that. So, yeah, see which one is assigned to the A facility. So it's A, B, and D. Which one is assigned to E? It is C, E, and F. Okay. So the more facility you open, as you can see, the less the objective. Why? Because you consider only the transportations. You don't care about the budget of opening the facility. That's why for your answer, you should be more critical. For example, the what is it? Yeah, you can see that, oh, the more facility I open, the better, right? That's your first assumption. Uh, then you will select, oh, 6 will be the best. But if you want to select less, I'm also okay with that answer. But remember, why do you select less? Normally, first, because maybe you say, oh, I have only one, I put assumption. One facility will take how many pesos will to operate, and then we only have budget for this amount of money. So at most that we can open is this one. You know that you want to use the most number of facility because the transportation distance is less, but you have budget, so you should allocate the budget as efficient as possible. Okay, for this one, actually it's easy. This one is, if you see, okay, it is equals to P median problems, but you consider the fixed cost of opening each facility. So here you just need to add, okay, maybe I don't have in the example, right? Yeah, I don't have it. Okay, here, for example, okay, let's copy first this one, paste, okay. Why does it not copy? Copy and then paste. Doesn't work. Let me do it from branch and cut node encounter. Is it of so? Helene, can you explain what do you mean with the branch and cut nodes?
Hello, sir.
Hello, hello.
Hi.
Yes.
We I am asking because this is the first time I saw here branch and cat nodes.
This one, right? Branch
Yes.
and cut nodes. Okay. So it's like this. The solver is automatically choose which algorithms they are going to use to solve the problems. Okay. Let's say your problem is simple linear programming. Let's say you have x1, x2, and x3. You want to minimize x1 multiplied by x2 plus x2 plus x3, and then you have several constraints. Maybe they will not use branch and cut algorithms, only branch and bound algorithm or simplex algorithm only. Maybe, okay. But for more complex problems, perhaps like p-median with more data, maybe, they may use another program, which is branch and cut, okay? So this show that what kind of algorithm they are using. For example, they use simplex several times and use branch and cut. How does it works? They don't really explain it here, okay? So, wait a moment, I have a call. Okay, so this show what kind of algorithms that the solver are using, the Gurobi are using. Okay, you don't have to worry as long as this one saying like this, optimal solution, something like that. Okay, and then the objective of something. If it has problems, normally it will show like, for example, let's say if you don't define the set here. Let's say, oh, I forgot to define the set here, and then I show model median dot mod. See, they will tell you that there is a problem. Oh, sorry, this one not here problem. Reset. Okay, model median dot mod. See, I is not defined. Okay, because we deleted earlier. Okay. That's gonna be that is a problem that you need to solve. But for this one, no need. It's already working well. Okay. Can I?
It
Yeah.
doesn't have any connection with the actual network. Like for example, in actuality, if I'm locating certain location,
Mhm.
I thought it will be like reroute or literally cutting the network like that. So
Okay.
it is not like that.
Yeah, the more complex your network, the more complex the data that you provide, maybe they will have more branch and cut. One cut, two cut, maybe more. Sometimes
Ah,
even they are not able to solve it. Okay. So yes, it has the connection. The more complex the data, the more cut you may have. But I cannot predict how many because it really depends on the algorithms on the network. This one, we don't study that detail. We don't study how they do the branch and cut. We don't study the how they do branch and bound because it's maybe their secret as well. Because several people, several company try to have like the best software for this one. Like there is a IBM with their Cplex, and then there is a lot of company. So maybe they will not share that in internal part of the how they do the branch and bound and branch and cut. But as long as we use it, and then it's easier to not understand that one also. That's very complicated. As long as we can use this one, I think it's okay already, Miss Henry.
okay, sir. Okay.
Mm-hmm.
Because during making of the assignment, it has been one of my choices. But since I do not know branch and cut, I did not select the p-value.
Mm-hmm.
So that's why I asked.
Okay, I don't think you have to worry about that particular how many branch and cut they are using, how many how to say, as long as your model works and then it can show you the result and then you can verify that result. I think for this that's already okay. That's already enough.
Okay, sir. Thank
Okay.
you.
Next, you see these problems. This is very similar with the p median problem, but we have more consideration in which we have the fixed cost and then we have fixed cost to opening each facility. So how do you modify that previous model? That's the question then. So here to do that, yeah, I try to modify that first here because we cannot do it from the AMPL IDE. So I open the folder and then I try to copy this part because we will do the same model, right? But we create the fixed cost, what is facility location problem, something like that. I don't know what's the name for that particular model. Fixed charge facility location problem, FCFLP, let's name it like that. FCFLP, CFLP. Okay, then we go back to the this one. Then we refresh here. We have this two file. Okay. Wait, what happened here? Okay. So here close fcflp.mod fcflp.dat. So previously, where is it? Here, right? So we have a fixed cost of using candidate facility J. So there should be another parameter. Okay, we call it F. That will be related to facility J. Fixed cost of choosing facility J. Facility at node J. So, and then what else? Here, you have F, J, yeah, and then you need to, oh, sorry, here, the objective value, right? Objective value, sorry, not there, this one. Fj multiplied by xj. So should be like this. So this one, sum j, okay, and then fj, sorry, that one k, multiplied by xj plus, okay. See, we have fj multiplied by xj plus h, di, and y. Okay, and then let's check model. Okay, sorry, stop it first. Yes. Okay. Model FCFLP dot mod. J is not defined. Wait, where is it? Fj sum j. Oh, sorry. Sum j in j. Okay. Stop. Press. Reset. Model fcflp.mod. Okay, it works. Now, but when we input the data, it doesn't work because we don't. We need to fix it a little bit. Wait, should be okay. Model fcflp.mod data fcflp.dat data. It should has this one. Maybe this. Model fcflp dot. Sorry. Should reset first. Model fcflp dot mod data fcflp dot chat. Huh? Why? Sorry about this. Oh, this one. Delete this. Okay. Data fcflp dot chat. Yeah. Okay. Let's reset it first. Reset model fcflp dot mod data fcflp dot chat. See, no error. Solver Gurobi. So, but it will error because we don't have the F value here, right? We don't have the data for fixed cost. Okay, let's assume that fixed cost for each J, so it will be F. Let's say the fixed cost is 5 for every facility. You can set it different later. One facility much more pricey than another one. You can change this part. But now let's have 5 as the facility. Cost to open each facility. Model FCFLP dot mod data CFLP dot that option solver Robbie solve. There is no value of P. Oh, sorry. The P itself. P is equal to 1. Set model CFLP.mod data CFLP.dat. P is already defined. What happened?
No param.
Oh yeah, param P. Thank you. Actually, you can write the run file like this one, this, and then include something to run. But yeah, later I will show you how to do that. Reset model CFLP.mod data CFLP.dat option solver will be solve. Yeah, see, display X. Remember previously we have result C with 55, but we added the fixed cost for opening that facility. So this one will be 55, but this one, you open one facility multiplied by 5 here, the cost of opening that facility. So you plus 55 with 60, then you get this number 60. Okay, that will be the answer for this 2 part of the question for our assignment. Okay. Up until here, I hope you already quite familiar with the AMPLs, because you can use that one for your final projects. Well, everyone, so that will be the week 3 and week 4 material. The details, please see again in the videos. Okay. And week 5, I already upload the file. You can study that one as you requested. Let's use that one as your midterm. Okay. And I hope you will be doing good as well for that one. So up until here, do you have any questions? Because I plan to wrap it up for the class. Maybe, yeah, if you all don't have question, then we can finish the class early as well. No question? Okay. So in that case, please try to finish the assignment 3, 4, and 5. Okay. So I hope everyone doing well. Yes, thank you. Okay. So thank you very much, everyone. Good evening.
Thank you, sir.
Yeah.
Thank you, sir.